Good day, this is Rutger Menger with another screencast for MCMS. Today I'm going to show you the cluster analysis that you can use to identify or actually classify different cases, so that's individuals as groups. You can do this for questionnaire data, when you have a bunch of questionnaire data and you're looking for groups, clusters of people in there. So what a cluster analysis does in broad strokes is it makes groups of people, it classifies cases in different groups, and these groups are homogeneous with themselves, so people in the groups are the same, and these groups are heterogeneous with each other, so the groups are not alike. So it's basically if you have a bunch of M&Ms in a bag and you turn over the bag, this cluster forms groups for red M&Ms, yellow M&Ms, green M&Ms, etc. The groups within are the same color, but there are different colors between. And of course, that's a simple example. This analysis allows you to run many more variables than just color. Why would you do such a thing? Well, obviously, if you want to segment a particular population, then you can do this. If you want to understand the differences in buying behaviors for different customers, then you do this. So, let's start with that. I've gotten a data set that actually is a data set that comes with SPSS. So you can find that in the sample folder in SPSS. You can open that. And then you can open this file and just actually do the cluster analysis with me. And what is important for this to understand for this data set, that it's about a telecommunications operator that gathered a whole bunch of information about their clients. That is obviously not exactly the same as what you are doing, but this example is quite straightforward and simple, so you can extrapolate from this example to your own data set. So let's talk about this data set, what's going on here. This is a bunch of demographic information, where people live, how old they are, whether or not they're married, what their income is, if they're employed or retired, their gender, etc., etc. Then there's a bunch of use information, which is about the services they pay for at a provider. So this is data coming from the provider. Who are the customers? What services do they use? And how did they use it last month? And over the course of their contract. And what are the properties of their contract? So this is telecommunications provider. So if they do use wireless services last month, or wireless services across their entire tenure. If they use the internet, if they have caller ID, if they use online billing or offline billing. These are just all the properties of different individuals. A thing here is that a lot of the data is actually standardized, which you can see here with this log and ln thing here. So that's a natural logarithmic scale and just a logarithmic transformation of the data. Why did they do this? Well, they standardized this data for a couple of reasons. First of all, if you are measuring stuff in different units and you still want to compare it with each other, then this standardization is a good idea. You can now compare stuff because they are in the same range of numbers. It also, you can do this to make sure that the outliers are reduced. That's a property of the math here. Just take my word for it that happens. And another thing that they did, but I don't actually want you to do, is you can cheat a little bit. Over here you can see a bunch of nominal variables. So that's either no or yes. They have multiple lines or they don't. They have voicemail or they don't. They have a pager or they don't. Yes, it's that old. They have the internet or they don't. You can standardize this and make these scores between 0 and 1 and not just A0 or A1. And that way you can make it look like this data. And then you can use it for different purposes. But that actually is cheating with statistics, so please don't do that. Why is this important? Well, you can actually only run cluster analyses on data that looks like scale data. So in SPSS, this is scale data. You can't run it on nominal data, the cluster analysis that we're going to do. So if you have data like this, you can't really use it to form the clusters. You can look at it afterwards. So basically we're doing a 3-step process here. We're deciding which variables we can use for creating clusters, then identifying the groups of people in those clusters, and because we know which people are in which cluster, we can add a variable that says, hey, this person is in that cluster, and this person is in that cluster, and this person is in that cluster. Then we can look at the other properties where we're not allowed to put in our cluster analysis and see if there are any differences there. But we're not using them to create clusters because we're not cheating with standardizing numbers. So that basically means that for you guys, you can use Likert scale items to create clusters. And if you have nominal questions or categorical questions, you cannot really use them to create clusters, but you can evaluate them afterwards. So, without much further ado, what's the first step in this cluster analysis thing? Well, the first step is to think. And I wrote down actually to pre-think. Think about what is relevant to separate on. Think about what is relevant to segment your target group on, to segment your customer base. In this case, for the telecom companies, it's useful to segment on usage. What parts of the services do they use? They want segments related to this, and then they can look later at properties of that segment. And for you guys, you want to have similar customers together or similar users bunched together, but it makes sense to bunch them together on something that is super relevant, that's related to actually something in your data set that is super relevant to segment on. And like demographics and certain psychographics, values, lifestyle, may not be that relevant to segment on. You maybe want to segment on stuff that's related to using your products, or looking and finding, looking for information, finding information, using and trusting information. If your service, if your client is about providing that information, about providing that content. So don't put everything in your cluster analysis. Think beforehand what is useful to segment on, use that to create the clusters, and then afterwards you can look at particular properties like demographics, and use them to illustrate your persona. But basically, the first and most important part of your persona should be what is the most relevant for that. And that's not gender and age. That is a secondary property. It's how they use your product, or what they use it for, or how they use your content, and what reasons they have to use it, stuff like that. So, the actual analysis you can find in Analyze and then Classify, and then you have this option K means cluster. That's the type of clustering we're doing. You can see that there are other types of clustering, but we're using this one. Don't do this. Leave that out. You need to put in the variables that you think are relevant for separating different clusters. So you take them from here, you put them in there. Then you have a couple of options. You can set how many iterations the model does. Basically, that means that it's a stupid algorithm. It really doesn't think. It just keeps on trying different models, and then the one that it stops when it hits a certain sweet spot. Sometimes it does this in 5 iterations. Sometimes it does this in 10 iterations, but it's good to set the maximum at 20. If it can't hit it before 20, then there is nothing to find. You can I can sort of illustrate this for you. Like if you go to find and buy new shoes, then you try to fit on different shoes until you find one, and you could do it really dumb, like an algorithm, just try to fit on every shoe in the store until you find one that actually fits. And this is how this algorithm works. It just tries on different shoes all the time until it finds one that fits fairly well. You don't want to try all the shoes, so that's why we have a maximum number, but you don't also want to try only a few, because then you might not find the one you're looking for. So 20 is the number we use here. And we're going to skip this. And at options, we have several options. And I want you to check all these and check that one. The initial cluster centers shows us where the model starts. Obviously, we're getting a final update on that in our results as well, so we can see what's happening. The ANOVA table tells us which particular variable gives us the biggest contribution in separating different clusters of things that are alike from things that they're not alike at all. And we can get information for cluster membership. So those are the options. We want those. We're going to skip this, skip this, that. And here is an important bit. We need to tell the model how many clusters we want. And actually a good way to do the cluster analysis is to run this with a couple of different number of clusters. So we can run it with 1, we can run it with 2, we can run it with 3, we can run it with 4. This is something you just put in. Because the algorithm is dumb, it will just try to fit the data to 2 clusters or 3 or 4. Let's start with 3 and see what comes up. The idea behind running this analysis a couple of times is to find out if there are clusters that are unnecessary, or if there are clusters that are actually hidden within other clusters. So you can imagine that if you run it with 3, then it might fit if there are actually 4 clusters in the data, and you run it with 3, then it's going to put 2 clusters together. And you can find that out by running the same thing with 4 clusters and then seeing, aha, here's an extra cluster that's separate from the others, and that was really helpful. You might also have too many clusters in your analysis. So if you have 3 clusters and there are actually 2 in there, then you're inventing clusters that are not really there. And when I say clusters in this regard, this basically is how many personas you want and how many personas are there. So you can run this analysis and find out there are 2 personas or 3 or 4 or maybe just 1. These are all possible. 3 is a good place to start because you can move up and see maybe there's 4. Do the properties and do the outcomes get better? If I run 4, or do they get worse? And you can look at 2. Do the outcomes get better if I use 2, or do they get worse? And then you can sort of hone in on how many personas are probably there. For this data set, we're going to start with 3. And you press OK, and then you get these results. I will discuss the results in the following screencast. This is it for now. Thank you.